Hello. So thank you very much for attending this this event, this presentation. So I'm David Rua, and jointly with Laura Daniele from TNO, we'll be sharing today the contributions to SAREF towards interconnected world of smart home buildings and grids, which is a part of the work that we're developing and alongside with other partners within the InterConnect H2020 EU project related with the issues with interoperability and energy and ICT data domain. So very quickly, just to introduce myself. So my name is David Rua. I'm part of INESC TEC, which is an R&D institution in Portugal, headed in Porto. Particularly, I'm part from the Center of Power and Energy Systems, INESC TEC, where we develop a lot of our research activities within the energy domain, but also tied with the data domain, of course. So I'm interested in research activities involving communication systems applied to smart grids and energy systems, and in novel management and control schemes within smart grids, and finding ways to optimize the use of energy within flexible resources that may exist within buildings, tertiary, domestic, and even industrial buildings. So I myself have been part in several projects at national and EU level, and I'm currently leading the H2020 InterConnect project. So about what we are talking about here today. So we are introducing this contribution that we are jointly doing, again, with other partners, regarding the add-ons to the SAREF, which is the base suite for the ontologies that we're developing here. So we're focused on contributing to SAREF on itself as a core development, also in the extensions that we are now having as part of SAREF 2, namely SAREF for an area and SAREF for building. So, and these are developments that we are carrying it out. Laura will talk a bit more in detail about these on her part. But in the InterConnect project, we are focused in making sure that we have interoperable solutions with our digitally connected, and are also integrating people and services within several flexible devices and systems within buildings that basically will be covered in several large-scale pilots in Europe. So as you will see in a while, we have a set of large-scale pilots, and as of September this year, we will see already a lot of the contributions from the project in this regard of the ontology side, specifically in the ETSI Smart M2M, and even in SAREF itself with the support of ETSI. The contributions that are being made towards the extension of the ontology basis. So focusing on the services is focusing on the technologies that are interconnecting to a specific plane or bus, in which it's possible to create add-on services that will later on be deployed within the large-scale pilots that I've mentioned, but also in making sure they are provided to the end stakeholders, which are not only companies within the consortium and R&D institutions you will see, but also general public and general people that will make use of these services in a non-interoperable way. So this is part of the discussion here today that we'll have to share with you. So about the project. So the InterConnect project is actually a very large project. So involves more than 50 partners, more than 70 entities with the third parties. And we are approaching these different domains within the demonstrations and the developments that I've just mentioned. So we are departing, of course, from existing work already done on SAREF. So ontology-based interoperability is one of the focus. We're also reaching out on the interaction between the digital platforms that focus on making sure that data is exchanged between devices, systems, and infrastructures, where we will be dealing with issues such as Internet of Things and interconnecting all of the devices and systems, but also to make use of the information that is exchanged with current trend technologies such as blockchain, smart contracting, again, for the services, and so forth. So on the third domain, IoT is, of course, one of the bases interconnecting the different buildings that will take part of this demonstration that later on I'll share with you. And with the ability to have the IoT domain cross-bridge with the cloud-based systems, we are ensuring that the information flow is made typically over different domains, but still with the concern of security and privacy at all points. So From one side, we have also the domain of the electric grid, which is also having their own challenges covered in the project regarding the standardized use of interfaces to foster the support towards market-based services and platforms to ensure connectivity with existing systems from typically system operators, but also with the demand side. And the final three domains I would like also to highlight here are related with big data, cybersecurity, and standardization. With regards to big data, it is expected that by interconnecting a lot of these devices, systems, and infrastructures, that a large flow of data will take place. So we will be applying state-of-the-art techniques, machine learning and artificial intelligence, where basically with the services entailed within the project, we'll be looking to foster, again, different business domains. With regards to cybersecurity, I already mentioned this private by design approach that we are setting forth here. So we only share the necessary information that needs to be shared for the services and not a single piece more. And at the end, we should have within the project, and this is a project that has a lot of the outputs, an interoperable marketplace toolbox and SAREF compliant basics, which will allow not only the demonstrations of the other parts to take it forward, but also others willing to adhere to also make use of the same platforms that the project will produce. So this is a project that it's open with a lot of the developments and a lot of the key implementations to a public audience, not only for the project itself, of course, as key stakeholders, but for others interested in joining in. We will have a cascaded funding. I'll talk about that later on. But with the impact that we expect to achieve, so as already was laid out, one of the issues that we need to ensure is the massive deployment of IoT systems, relying on standards and platforms that are interoperable, not trapped within loopholes of manufacturers or implementers on proprietary approaches. Also to make sure that we have a clear impact in the use of energy, applications, services, devices, and appliances, to make sure that the flexibility that right now can be exploited from the demand side is actually readily available, integrated with different types of devices and systems that we have within the buildings. And we're talking about, for instance, electric mobility, renewable integration as the energy front, but we're also covering the non-energy side because we have services and we separate the project as energy and non-energy. Then in energy, we are of course talking about the comfort, convenience, and data. Within data, we have then again security and privacy to deal with. So as part of this, and because the user needs to be a centerpiece here, we need to focus, and we are focusing also on ways to make sure that the services that are being developed do conceive from the very beginning in user acceptance, and focus also on co-creating services and user-centric design to make sure that those services at the end do meet the criteria of the users themselves. Either they are the final end users like we all are for these services, or other types of users like building managers and so forth. Mentioned already this marketplace for services as something that will allow the fostering of technology to be linked together with these new services within the EU landscape. So it's all about bridging up together buildings, domestic, non-domestic, where by joining them together, we can unlock new opportunities for SMEs and startups. And at the end, as all of the contributions of H2020 projects is to focus also on the matter at hand, which is to decrease the carbon footprint of the energy use. So finding ways of using more efficiently the resources that we have. So as outputs of the project, again, we're focused on the customer side. You can see on the right side how to improve this experience that the user has, and how can we make a democratic access for energy management, how the digital marketplace and toolkits are available for service providers and takers to deploy digital platforms and to make use of existing technologies such as peer-to-peer, blockchain, and so forth. Also, the fact that one of the key domains here, when interconnecting the demand side, the buildings, they do rely on an existing infrastructure, grid infrastructure, electric infrastructure, which is managed and it's supported by the system operator. So the distribution system operator is also something that we're focusing here in making sure that also these tools, or part of these tools, are also available for DSOs. Business use cases, it's something it's already public, so you probably can see it in our website. It's also part of this presentation, the link, where you can have already this as a public output, a set of business use cases that we believe will be fulfilled within the demonstrators. Again, covering energy, non-energy. And with this, also the number of components that Laura will talk about in a while on the SAREF way. So we are actually creating functional components which are SAREFized, that then are able to speak at the same plane of interoperability and basically make use of the different connectivity architectures that are already put into play. And of course, hopefully by the end of the project, we should be in a good position to suggest and to recommend additional standardization outputs within the project. So going into the large-scale demonstration of the project, so it's basically divided into 7 countries. Each one of the demonstrators has its own theme. You can find a bit more on this on the project website, but just to highlight the specificity of each of these demonstrators very quickly. So we have a large residential community with smart appliance TV integration in Greece. Then from France, we have residential and non-residential with tertiary buildings and apartments. Portugal with residential and geographical widespread tertiary buildings. Netherlands, also the residential, non-residential. Germany, groups of residential buildings with a hotel, so a bit of a distinctive part there. Belgium dealing with clusters and domains of communities within multi-vector approach, and Italy going for the social housing also as part of building. So quite a set of diversity within each of the demonstrators, which will share, of course, some commonalities there. And basically, this is where we will be deploying all of the developments that we're carrying out in the project. So this is where interoperability will take place. So this will start October this year, so where we'll have already the first parts of interoperability laid in with the SAREFization of the first components for that. And then throughout the following 2 years, we'll have these demonstrators ongoing in each of these countries, which we will be happy enough to report publicly within deliverables and outcomes within the site of the project. So this is just to give you a glimpse of a very large consortium that covers different chains here, from IoT to the energy side. So R&D, consultancy, manufacturers, associations, and then providers, and there are several of them to take. So this is just to give you a glimpse of who we are. So we are fortunate enough to have those implementing these solutions into their actual business and their system. So this is part of our DNA. Just to finalize my last two slides, this is our milestones. So we are focused on the first stage on the use case and business models that we've already completed. So very soon you should see also on the website our final use cases from the business, technical, and functional side. Creating in the meantime this domain interoperable reference architectures, this SAREFization that I already mentioned a while ago, which is something that Laura will again talk a bit more, and then to create this framework for smart grids, digital platforms, and marketplaces, and then to demonstrate this on our own pilots, and also, as you will see in the next slide, in Cascading project that could adhere to our InterConnect project, where other stakeholders outside the project will have specific calls to be part also of this interoperability front. So, and with this, I'll conclude, which is this project also will have cascading initiatives. So besides this developments carried out within the consortium itself, we'll also have the opportunity to increase this innovation uptake with interoperability with other ecosystems that follow the same rules of engagement that we're setting forth for ourselves as partners of the project. And this is basically will be converting to 3 open calls that will be launched to select 42 innovative bottom-up projects and 14 prototypes and 28 small-scale demonstrators. So what does this mean? This means that companies, R&D centers, and other institutions have here an opportunity to also join this idea of interoperability and development, that basically will have financing available to them to adhere to this process, and then to be able also to post within our marketplace of applications their own solutions that can create value for other domains and other business models. So this will be available in 2022, so stay tuned. And in 2023, you should already see the first prototypes and small-scale demonstrators being executed. So thank you very much. And with this, I'll pass on the floor to Laura to her part of the presentation. Thank you very much.
Thanks, David, and thanks everyone, and welcome again. Hello from my side. My name is Laura Daniele, and maybe if we go to the next slide, there is something about me. So you can read that. I think what's most important to say is that I am, the creator of the first version of SAREF, and I've contributed, I'm still an expert in ETSI and Smart M2M about SAREF and all the extensions that have been created so far since 2014. So besides this role of standardization and semantic expert in SAREF, I'm also part of the InterConnect project, and David just explained what the big challenges that we are facing there. And I work for TNO. I'm a scientist at TNO, which is the largest Dutch independent research organization. And what we do is to bridge the gap between basic research and the industry. So enough about me. So if we go to the next slide, what I want to focus here in this last part of the presentation is the contributions to SAREF, which will then become hopefully a contribution also to the ETSI world of SAREF ontologies. So the focus, as you can see, is in this part, where we are now in April 2021, and we will have the first deliverables in September 2021, so in some months from now. And what we want to show today is these ontologies, so the ongoing work about the ontologies that are being developed in InterConnect, reusing and extending SAREF, already the basics of SAREF that are standardized in ETSI. If we go to the next slide, this is a little bit of the timeline of the ontology development in InterConnect. The project started already in at the end of 2019. Then in 2020, we started with the work on semantic modeling and the ontology, but really the focus, the big work started then in 2020. We follow developments with several workshops because this was proved to be extremely successful already in the first study when we created SAREF with the European Commission and ETSI. So this is very important. So you can see also here a sequence of workshops with the stakeholders, with partners, especially in such a large project. As David explains, we are 50 plus partners, and it's really tricky to find a consensus, to explain and to get everybody into the same page. That's why all these workshops here. And offline also, we had, of course, a lot of work also concerning the ontology development, concerning a lot of interactions with partners, so with domain experts, and in order to come up with some SAREF extensions. So where we are now is exactly where the red line is. So we are in April, so we are going to have our third workshop very soon, actually next week, where we have an ontology, a stable draft of our ontology. And what I'm going to show you now, it's what's a little bit in this draft, especially compared to what's already now in SAREF. So what's adding to SAREF, and what's important for all these partners, and especially also these manufacturers and industry partners, in order to make SAREF a reality in practice and really in their implementations embedded in their platforms. And what will happen then later is that we continue, and our goal is to have the ontology finished and documented by September this year, and then starts the process of actually contributing, so submitting these contributions to ETSI by using the ETSI portal for SAREF, for the SAREF community of users. So in this sense, we will be really the first big group of users testing the SAREF portal. That has been a big investment of ETSI in the last years, and also a great result, honestly, of which I'm also very proud of that we achieved in ETSI in Smart M2M. Having said that, maybe we go to the next slide. And what is the process? This shouldn't be anything new for those the ontology experts and the people who work in Smart End-to-End, because this is the ontology development process that we have always used in ETSI to develop all the SAREF and SAREF and all the extensions. The difference here, well, it's so I will not say too much about that because it's also very well documented, and it's also a normal actually ontology engineering process where we start from the specification of the requirements, use cases. In the case of InterConnect, as David mentioned, there are so many use cases because there are so many pilots and so many partners. So in the usual development of SAREF extensions, we usually pick up 3 or 4 use cases, plus all other documentation and standards and a data model that exist. Here in InterConnect, the challenge is quite big because then there are so many use cases for energy and non-energy services in the whole project. So we couldn't go through all of that individually, but we try to figure out the commonalities of these use cases to extract the elements needed for the SAREF extensions. And we transform them in the form of competency questions, as usually done in the SAREF approach, for making them later concepts and relations into the ontology. So now we are in the phase of the implementation, where we have implementation and formalization in a language which is RDF-OWL, the language that we use for all the SAREF and all the extensions. And that's where we are now. And later on, as I mentioned, we will go in the phase also of the ontology maintenance and evolution, which is like we have the finalization of the ontology, and then we start submitting these things also to ETSI. Next slide shows that we do also have an ontology repository that in this moment where all this development also and the community of partners of InterConnect contributes to the SAREF development, which is a repository that actually resembles the SAREF repository that we have in ETSI. However, for the moment is internal in InterConnect. We are developing this stuff now in the project, and later on we will submit these things also to the normal SAREF standardization specification process in ETSI, and therefore the documentation will be also moved to the SAREF repository in ETSI, if approved, of course, according to the workflow that we have for submitting SAREF extensions. The next slide shows what it is about, this ontology. Now, this is the smart energy reference architecture that we have in InterConnect. Unfortunately, I cannot go into all the details of this. And in the bottom of the page, you see the deliverable, which is a very interesting deliverable, actually, which contains a lot of information that you can read and find all the details about this. In general, what you see here, you see basically the home and building domain, the premises, where there are several types of devices, energy, non-energy, sensors, smart meters, and so forth. Then there is on the left part the human, the user part that interacts with the environment. And on top, there is the InterConnect framework. I would say better framework than platform, because we're not building yet a new platform. We are just connecting the existing platforms in a framework. And you see then the information that it's exchanged on the top with what's more like control, comfort, and convenience services, which is more the control part and more the typical IoT services part, and also more energy services. And then you see energy providers and possibility to forecast, having services for forecasting and energy flexibility. And on the right part, you see the other domain that we are integrating, which is the grid domain, where you have the energy market, the TSO, transmission system operator, BRP, DSO, distribution system operator, and so forth. And all this is a very complex landscape of actors and interactions. But what is highlighted here is the type of information, main objects information, that we are going to exchange, that it's important for the use cases, for the platforms, for the partners to be exchanging there. And we can summarize then in user information, some sensor information, which is mostly about non-energy service, so about IoT, let's say, services, actuators, and so forth. Then there is forecast information, some device information, especially when looking at devices that offer flexibility, energy flexibility. Then there is part about flexibility, and then there is part about really the smart grid connection. Now, if we go to the next slide, this was actually a transition to show what we're doing here and what's the relation to SAREF and the already existing suite of ontologies in ETSI. On the right side, you see that, of course, we have SAREF and all the extensions, and I think the most relevant ones are then SAREF for energy, SAREF for building, and SAREF core, although even other parts might be reused. And then we have the InterConnect on the left, new concepts based on these building blocks that I just mentioned. So we are designing and realizing several new, how to say, building blocks that can be added to SAREF concerning this topic, this user info, sensor info, forecast info, and so forth. And let's not forget also in the top part that both SAREF and, of course, also the InterConnect ontology will reuse also other existing ontologies. So it's not only about SAREF. SAREF, it's there when it's important to use it, but there are also, of course, other ontologies, existing ontologies that we reuse and should be reused. That's the vision that we have also in ETSI. One note is that connection info, really the part with the smart grid, it's a tough and tricky part. Well, all of them are, but this most than anything, because the alignment of SAREF with models and standards for smart grid is a very long process. Take, for example, the ICC model. So how do you align the two models? They belong to different SDOs. One is, for example, in a UML format. One is in an ontology in OWL. So it's a long way to still get together. So InterConnect will not be able to give an ontology, to define an ontology about that, but for sure we will make some steps. And I think it's good to set the expectations here, that the contributions we're talking about here are about the other parts, and we will see what are the steps that we can do about the relation and alignment with the smart grid part in the ESOs. Then maybe we go to the next part, which these are, so it's not meant now, this presentation, to go extensively to these terms and concepts, but I want to just show you something, what's happening in that. So I'm giving for granted that actually you know a little bit what is SAREF about. In the slide set, anyways, you will find at the end some backup slides if they're made available with the model of SAREF. Now in this moment, SAREF is about devices and measurements as observations of something that happens. What we are adding, for example, for the purpose of forecasting services is the fact that measurements can be actual measurements that actually exist and that have already taken places, but this could be also measurements, predicted measurements that will happen in the future that we are forecasting, and also that sometimes these measurements can be corrected or even estimated. So it's a little bit of addition to SAREF in specifying a little bit more what type of measurements can be done in there. Then the concept of forecast is an addition, something that does not exist in SAREF, which, as we said now, focus on the actual measurements and observations of properties that can be sensed or controlled by devices. And therefore, we have forecast concept with types of forecasts, because we can have quantile point forecast trajectories. And we're not looking into the specific algorithms for forecasting, the machine learning parts and so on. We're looking at the output that this generates that can be used then with SAREF and transformed into concepts that can be exchanged via SAREF. Then there are, then there is a forecast horizon, some properties like the update rate and launch time. And the important thing is that a forecast is a sequence of predicted measurement. Forecast is something that will happen in the future. Therefore, we make it as a sequence of measurements, of so-called predicted measurements, because these are going to be in the future. And when you want to see how a forecast looks like, well, then a forecast is actually something that is expressed as a time series. And time series is a concept by itself. So it can be used also not without forecast, but time series is very important because SAREF now only allows to use measurements, but in this case, we need, the reality is that time series are exchanged most of the time, and especially in this type of forecast services. So time series are then sequence of measurements, SAREF measurements, and these measurements can be any type of measurement, actual or predicted. That depends. So if it's a forecast, it will be a predicted measurement. If it's some other things, it will be just actual measurement, for example, and so forth. And those are measured at a location. And there is also the possibility, we add the possibility to specify the type of value of this measurement that before was just general has value property in SAREF, and now becomes also, it adds the possibility to say if this value is an average value, cumulative value, maximum value, or minimum value. I think I'll go to the next slide. I'm already going quite into some details of this, but another important part is the user information. SAREF now is about the devices, and on purpose in the previous year, we never added the user and the user concept. But now it is important, at least in InterConnect for sure, because what happens there and the services that are offered, the user plays a very important role, because we need to take into account what are the user preferences, what the user wants, what are the user behaviors, how we can learn also from these user behaviors, how users can learn from the behaviors of others, and so forth. Therefore, we need to add something, like we found the need to add something, a concept of a user who has a user profile. We're not interested in that about the specific data of the user, about who is the user and so forth, but about some generic things that let us know, and we can express in the ontology, for example, that they have a profile. So a user can be, for example, a resident or can be a building manager, and there can be different profiles of this person. So if I'm a resident in my apartment, I can have a profile for when I'm working, or a profile when I am relaxing or reading something. In that case, we can set at time and in which location what is the interest of the user and what activity. So if I am reading, for example, I might have some user preferences. And these user preferences are related to certain devices. So I might want to set the light in certain ways. I might want, and therefore my lights will receive some commands, because maybe if I'm reading, I want the light to be dimmed to, or watching TV, I want the light to be dimmed to 60%, things like that. And even the preferences might have even a priority. So sometimes something is more important than something else. And then some other concepts like user interest and activity. So these are the things that we believe it's important to add also to SAREF. Then we have next slide, which is about the flexibility info. So the energy flexibility is the possibility for the user to offer the flexibility for tasks that need to happen concerning the devices in the home. And the smart grid gives some flexibility, has some flexibility to do these tasks in certain times or depending on certain prices and so forth. We have some patterns of flexibility identified, and you can see here what those are. So the part in the identified here is there is some part that is already covered by SAREF for energy, the version that we already have, especially in terms of power profile, alternatives groups, power sequence, and slot. There are other parts that are important to cover for other devices, as you can see, because we have a lot of PV panels, for example, in all the use cases of InterConnect. We have things like devices for that buffer energy, like, for example, hot water boiler, devices for storing energy. What more important than that? We have all these use cases with batteries, which could be stationary batteries or batteries even in electric vehicles, are so important, and so forth. So we are working on this part. So to add something to SAREF for energy, that's for now it's the version 1.0 that we originally developed to cover the power profile together with EBUS and Energy at Home associations. And now we are adding many more partners to that, more associations of partners, of manufacturers, which is going to make SAREF for energy even more important, with a more consensus and really with much more impact as well. If we go to the next slide, then this is the last one, and it's about the sensors and device info. So another addition that we have done so far, and we will hope to submit soon, then is in terms of more sensor and actuators types. So SAREF already has device types modeled, but then we are adding more and more because we have more and more use cases and more fancy actually services that we are offering in our pilots. So we are explicitly modeling in SAREF more sensor and actuator types with the related associated function, state, and commands and properties. And you can see a list of them: motion sensor, multi-sensors, contact, sound, and CO2 detectors, and more things like that. And on the energy side, the flexibility side, we are modeling now these additions to be used in the pilots. These other devices, energy devices, which are of course smart meters with more details on that. And as mentioned, solar panels, charging stations, electric vehicles, batteries, and so forth. And also HVAC and especially also, we also have the supermarket pilot in Portugal, where we will have a lot of these HVAC units that will need to play a role in that, and we need also to define them a little bit better. I think this was the last slide, so I will conclude here because we went quite into some details, but of course, you can contact us for more information. I think that the message to remember now is that InterConnect is doing a lot of big work in these large-scale pilots, that SAREF is absolutely a requirement for InterConnect, for the pilots in InterConnect. So we will see very soon SAREF working in reality in our homes via the pilots. And for having that, we are adding some concepts that are necessary, that are not yet in the SAREF suite of ontologies, that as we have them in ETSI. So immediately after this work, as of September, so starting from the end of this year, we will also start contributing is to ETSI, being also really some user and testers of the development environment of SAREF that ETSI has launched in the last time. That concludes. Thank you very much for your attention, and David and myself are available for questions offline. You will find our email addresses in the presentation. Thank you very much.